I slipped in V equals IR up here. We'll refer back to that in a minute. But let's take a look at the relationship between the maximum voltage through an inductor and the maximum current. So what's the relationship between maximum voltage and maximum current for the inductor? Think about that for a minute and see if you can write down the relationship between what we could call V sub L max and I max. Then think through the same thing for the relationship between the maximum capacitor voltage and the maximum current. Okay, well hopefully you've done that, and let's see what that is. Well, the maximum voltage across the inductor occurs when cosine of omega t is 1. Cosine of omega t is 1 and has magnitude 1 twice per cycle. It's 1 and then negative 1 in a cycle, like here and here. And of course that's multiplied by L omega I max. So if the cosine of omega t is 1, then we have the maximum value of the voltage right here. So the maximum voltage is L omega I max. Okay? What about down here? Well, the maximum value of the cosine is 1. It goes 1, negative 1, so the maximum of Vc will occur when the cosine omega t is negative 1 in this case. And that maximum value is going to be I max over omega c. Okay? So we could write that down. The maximum voltage across the inductor, V sub L max, is omega L I max, and across the capacitor, Vc max, 1 over omega c times I max. Now, in a few minutes, we're going to put this into a phasor diagram and totally make sense of the phasor picture, okay? Because this is all we need to really make sense of it. This and the fact now that we know that we have the 90-degree difference in opposite directions of the phase between the current and the voltage. Okay, now by analogy with the fact that the maximum voltage across the resistor, we haven't mentioned the resistor, but we'll just mention that the voltage across the resistor is totally in phase with the current because voltage is current times resistance. Just a constant. There's no derivative involved, nothing to shift the phase, and there's nothing in the physics of the situation to shift the phase. The voltage is, well, the current in this case is a straightforward response through the resistor to the voltage, okay? And it's an instantaneous response. Okay, well, by analogy, we can write and let me pause a second. Excuse the pause. I wanted to double check your book for the symbol. I don't look at your book that often. Wanted to use the same symbol for reactance that your book did. I also wanted to make a decision about what color to write these in. Since I use blue up here, I'm going to use blue down here. Okay. So we could write VL max equals XL times I max, and VC max equals XC multiplied by I max. And to be complete, let's just write VR max. And I didn't write the R here, just to be consistent. Let me slip an R in there, even though it's offset just a little bit from where it should be, is going to be R times I max. Okay, we see that this quantity XL and this quantity XC, XL equal to omega L, XC equal to 1 over omega C, act just like R in an equation that determines voltage from current. Now this is maximum voltage against maximum current. In this case, it wouldn't matter, but here it does kind of matter that we're looking at the maximum. So that XL and XC act very much like resistance in reducing or increasing the voltage necessary to push a current through the circuit element. So we can also write X sub L equals omega L, and X sub C equals 1 over omega C. Okay, these are called reactances. And I'm not going to write it, but this is the reactance of the inductor. This is the reactance of the capacitor. Okay, so now we have some terminology. These quantities, reactance, you should understand, act a whole lot like resistance in, again, the determining relationship, at least between maximum current and maximum voltage.